I'm just put the PPT. Can you see the slides?
Yes, sir.
Okay, I'm changing. Oh, wait, what's this? Hello? Are you able to see the slides?
Yes, sir.
Yes?
Yes, sir.
I'm changing them. Can you see the
Yes,
clear?
sir. Yes, sir. It's clear.
Okay. Okay, welcome to Department of Chemical Engineering, Banastali Vidyapeeth. We are on CHE 305 Chemical Technology lecture number 22. We now enter, so far we have discussed mostly inorganic industries. Right. All that ammonia, urea, caustic soda, chlorine, sulfuric acid, nitric acid, phosphoric acid, cryogenics, uh, cement, right? Coal combustion, coal technologies, they all broadly come under the inorganic industries, say. Now, time for us to move into one major segment of the chemical industry, the petroleum industry. In a way, you can say that petroleum industry is chemical industry by itself. Right? Today, the chemical industry is divided as petroleum industry and oil and gas industry, which is in short the petroleum industry and the remaining industries. So it is one standalone giant dinosaur. And we are going to have a look at it in the next couple of lectures. What is the petroleum industry? Well, the term petroleum, you can see, it refers both to crude oil and natural gas. These are mixtures of hydrocarbons, which are molecules in various shapes and sizes of hydrogen and carbon atoms, mainly hydrocarbons, and different mixtures of hydrocarbons. They have different uses and different economic values. What you use for an aeroplane, you can't use for a car. What you use for a car, you can't use for a truck. So there are many differences. They're all hydrocarbons. They have different uses and different properties and different values. You know the difference between the price of petrol and diesel, right? There was a time when diesel was almost half the price of petrol. Slowly it has caught up, right? Now, crude oil refers to hydrocarbon mixtures which are produced from underground reservoirs that are liquid at normal atmospheric pressure and temperature. So, crude oil is something which is under normal atmospheric pressure and temperature, it is a liquid. Only when I change the condition, it forms, gaseous products, etc. Okay. Natural gas refers to hydrocarbon mixtures that are gaseous at normal atmospheric pressure and temperature. Remember, the difference between crude oil and natural gas is crude oil is a liquid at normal atmospheric pressure and temperature, whereas natural gas is a gas at normal atmospheric pressure and temperature. The gas mixtures consist in natural gas largely methane, which is the smallest natural hydrocarbon. Remember, methane is the smallest possible hydrocarbon, 1 carbon and 4 hydrogen. Right? 1:4 ratio. The extremely variable compositional complexity of petroleum reveals the joint effects of all processes involved in the origin of petroleum. Remember, crude oil consists of a whole kitchari of hydrocarbons, right? And how complex they have been formed. It all has something to do with the origin of petroleum. We will see quickly how the petroleum crude oil originated. We'll come to that. And hydrocarbon reservoirs are porous and permeable host rocks. Right. See, you must remember that we are talking a bit of geology, meaning there is a source rock where the oil formation took place, and then there is a set of porous rocks through which the oil and gas pass through and reach, host rocks, right? So you have source rock, the intermediate rocks, and then the host rocks. Okay, they are thousands of feet below the surface. They are thousands of feet below the surface, and oil and gas accumulation form in oil and accumulation. They form in sedimentary basins if some geological conditions, which is shortly known as petroleum system, is met. Okay, now sedimentary basin, sedimentary rocks, right? And so let's see some of the components of petroleum system. If these conditions are met, there is the existence of source rocks which generate petroleum under particular subsurface temperature condition. So you have something called, remember, in this slide, we are having one glance of geology, which is a field by itself, right? So there are source rocks where the petroleum started forming, and expulsion of petroleum from the source and subsequent migration. So where it formed, it did not stay. Then it got expelled from the source rock and started migrating. And then you have reservoir rocks. Reservoir rocks have sufficient porosity and permeability, allowing flow of petroleum through the pore system. So you have reservoir rocks through which the oil and gas is flowing and getting accumulated, and configurations and arrangement of rock layers to form traps. So an arrangement of these rock layers end up forming a trap where the oil gets trapped, and presence of impermeable layers, which are known as cap rocks. Cap rocks is like, bottle ka dakkan, right? So a bottle is there, the oil is there, and cap rock is the dakkan, which is impermeable, meaning it sits above the, what is this, what is that, a trap, so that the oil doesn't leak anymore or doesn't travel anymore, confines petroleum accumulation in place. So the cap rock sits above this. Correct timing with respect to the sequence by which all the above processes have occurred during the history of a sedimentary basin. Advantageous conditions for the preservation of petroleum accumulation during the geological time. When I am saying geological time, it's thousands and thousands of years. Okay. Now, oil industry uses three distinct terms, jargons: upstream, midstream, downstream. Upstream is also known as E&P. E&P stands for exploration and production. Right? Upstream, midstream, downstream. What these things mean? Upstream, this refers to anything having to do with the exploration and production of oil, how the oil is explored and produced at the oil well of oil and gas, and geological surveys and information gathering used to locate specific areas where minerals are likely to be found is called exploration. Right? That is searching for oil. And then the term upstream also includes the steps which are involved, like actual drilling of a well to lift the oil from the bottom to the top and bringing the oil and natural gas to the surface. This is known as production. So searching for oil is exploration, and after exploring, drilling a well and lifting the oil and gas to the top surface is known as production. That is why it is E&P, exploration and production. In short, it is known as upstream. Be familiar with all these jargon. When you go to ONGC Indian Oil, they'll be talking all these words and you should know them. Midstream. This segment of the oil and gas, remember, where the oil is drilled, the refinery may not be located there. Say the oil is drilled in Gujarat coast, but the refinery is in Mathura, the refinery is in Panipat. So how does the oil come from the Gujarat coast to Mathura and Panipat? So the transportation of the oil, right, that is what is midstream. Midstream is all that operation between the production and downstream. Downstream is where the petroleum refining takes place in the refinery. So you have huge pipelines bringing the oil from the drilling point to the refining point. They are all fall under midstream. Or you are having oil from one country, crude oil is there in one country and it is brought to another country for refining. So shipping, tankers, oil tankers, super tankers, all that is midstream. So midstream refers to anything required to transport and store the crude oil and natural gas before they are refined and processed into fuel, and key elements needed to make a very long list of products we use every day. Midstream includes pipeline and all the infrastructure required to move these resources long distance, pumping stations, tank trucks, rail tank cars, transcontinental tankers. Remember, oil comes from, say, from Mexico to India, right? So transcontinental tankers, super tankers, which come from one country to another carrying thousands of gallons of oil, right? So that is all midstream. Then comes the last, downstream. This includes everything involved in turning the crude oil into and natural gas into finished products, right? And which is our everyday life we use, like gasoline, that is petrol, diesel, kerosene, jet fuel, heating oils, asphalt, plastics, fibers, elastomers, dyes, paints, etc., etc. This is all downstream. So it's clear, you have three things: upstream, midstream, downstream. Upstream is exploration and production. Midstream is transporting from the drilling point to the refining point. They may involve pipeline, trucks, rail wagon, tank cars, and super tankers, transcontinental tankers, etc. Downstream is where the crude oil, having so many products, end up becoming products. So crude oil, remember, is a khichdi of many hydrocarbons, and we are removing them one by one in the refinery the way we want, right? That is the downstream operation. So I hope it is clear now what is upstream, midstream, downstream. Look at this figure, upstream. This is where oil is being drilled. It is an offshore location. There is not much difference between onshore and offshore, except that offshore, remember, it is in water and it may be a floating platform, and many different designs of offshore, drilling vessels are there. There may be special ships which are designed for drilling offshore. So there are many kinds, we are not getting into them. So this is the exploration and production, right? What all is happening here, right? So oil and gas drilling, oil and gas service and equipment. So it's all happening upstream. Then comes midstream. Midstream is energy infrastructure, right? Transport oil and gas via pipes, pipelines, and storage of excess, right? So remember, close to the Banastali campus, there is a place called Chaksu. All of you who come by bus from Jaipur to Banastali, will be passing through Chaksu, where in the bus stand they sell those milk pakodis also, remember, right? And Chaksu is a storage space for the oil from Gujarat, which comes up to Chaksu in pipeline, and from Chaksu, two different pipelines take it to Mathura and Panipat. Okay, we wanted to take someday. We will plan to take you to Chaksu to show you how thousands of gallons of crude oil is stored there. Right? Remember, it comes from Gujarat coast via pipeline to Chaksu, and from Chaksu it goes by pipeline to Panipat one line and Mathura another line. Interesting. Right, next door to us, crude oil and refined products. Similarly, you have pipeline which carries the product from the refinery to different locations. So remember, midstream refers to both bringing the kacha mal to the refinery as well as taking the pakka mal to various other places. So if you go to Google and search for the pipeline division of Indian Oil, you will see a whole network of pipeline of Indian Oil across the country, carrying crude oil to different refinery and carrying finished product to different industries. Remember, from Mathura you have a pipeline which takes, petrol and diesel to Delhi, right? So finished product goes there, right? So you have pipeline not only to bring crude oil from Gujarat to Mathura, but also to take from Mathura the petrol and diesel to nearby states, right? So the midstream handles both ends, right? So this is midstream. Then comes the end stream. End stream is where the crude oil comes to the refinery and becomes finished products, right? So that is the end downstream, right? So upstream, midstream, downstream. We get going. Now we come to fundamentals of upstream. Upstream is a term used in the oil industry which is used for exploration and production. We have already seen that. Exploration is searching for potential onshore or offshore oil and gas reservoirs and the drilling of exploratory wells. And production and maintenance, see, drilling of exploratory well means it's only a trial to just see oil hiking, right? Production and maintenance of wells and facilities to recover and bring the crude oil to the surface and to process the produced carbon. So exploration and production. Within the upstream, a typical oil and gas operating cycle sees several different phases which aim to target varied goals using specialized technologies. Remember, exploration and drilling is a very special operation for which a lot of patience and expertise is required. We'll see some of them. A schematic representation of what all happens in upstream is given here. Basin area assessment. Basin area means where the oil is likely to be found. There are regional studies, geological modeling, then contracts are given. Bid means contract, right? Contracts are given, evaluated, and then you search for opportunities in a given area where oil may be found. Prospect definition and discovery. You do seismic survey and interpretation. Seismic survey is a specialized survey. We will just see it shortly. Drilling, right? Drilling operation is done. Then subsurface geology, what is there on the below the earth surface, and then production tests, and then reservoir delineation and modeling, appraisal drilling, reservoir studies, reservoir modeling, feasibility studies. This all is there in this field. Development, developing a plan and environmental aspects, drilling and completion, surface facilities, construction and installation. See, oil will be found in very remote areas where you have to build everything for a living, right? Production management and optimization, reservoir management, abandonment. Once the well, you have extracted oil, you have to abandon the well. That requires well plugging, plant removal, right? And environmental restoration. So many things are involved. So don't think that exploration and drilling is just a very small activity. The whole lot of activity goes on there. Now, it's time for us to have a look at the origin of petroleum. Okay, so far, origin of petroleum is somewhat similar to coal. Of course, they had the similar beginning, but the ending was different, right? So it's like different Bollywood film where the movie starts in the same way, but ends up, with a different ending, right? So, like, two brothers missing, finally they both get together. That is one story. Two brothers missing, and finally, one becomes a policeman and the other becomes a, what do you call, smuggler, and they fight each other and kill each other, right? So, story ending. So, petroleum also has got a similar story which starts like coal, but the ending is different. Humans have used petroleum since biblical time, and yet the origin of the source remains a mystery. Still, we wonder how the petroleum formed. There are two types of arguments going on. It has been one of the longest running scientific debates whether petroleum is formed by a biogenic process that occurs deep within the earth or from sedimentary organic matter that was once living organism. Just look at these two lines. Abiogenic process means it has no biological origin. Some mysterious things happen below the earth by which oil is formed. Right? That is one theory. But the other theory is like coal, you have sedimentary organic matter. They were once plants and living organisms. They all got buried, and over time they decayed and formed into organic products. Coal ended up becoming a solid, and more action ended up converting it into by more hydrogen, etc., into a liquid, that is crude oil. Okay, so there is a biogenic process and a process, biogenic process, which is somewhat similar to the coal. Now, you may be wondering, what is this abiogenic? Abiogenic is, means oil was formed by some mysterious reactions in the earth, which is not known to us. But it has nothing to do with plants and animals. Right? Below the earth, some God say reactions are happening. Remember, everybody knows now the earth is rotating around the sun. But there is still in the world a small set of people who believe that sun is actually rotating around the earth. Right? You search the internet, you will find. Right? So they think that earth is in the center and sun is going round and round it. But the other theory is, the earth is going around the sun. So similarly, in this also, you have a controversy, but try more reason to believe that the second one, biogenic process, is responsible for the formation is more accepted than abiogenic. But please do not rule out abiogenic. There are proofs to show that small quantity of oil in the earth may be formed due to abiogenic process. But most of the oil formed has been attributed to biogenic, but abiogenic could be a very small fraction, right? So very, very small, but not ignorable. But by and large, the biogenic process theory has been accepted, right? And we'll see it. As fossil evidence emerged during the 18th century, that coals were derived from plant remains. We have seen in the coal technologies that plants all got buried down, and then peat was formed. Then peat became lignite, lignite became subbituminous, and subbituminous became bituminous, bituminous became anthracite. In a similar way, organic matter only was the starting point of petroleum formation. Okay, modern theory is that petroleum originated from ancient sedimentary organic rich rocks emerged during the 19th century. T.S. Hunt of the Canadian Geological Survey concluded in 1863 that the organic matter in some North American Paleozoic rocks. Remember, Paleo is the period in the evolution of Earth, thousands and thousands of years ago, right? Rock, they must be derived from marine vegetation or marine animals, and that the transformation of this organic matter to bitumen must be similar to the processes involved in coal formation. Of course, there is more belief that petroleum originated in marine location or close to marine, right? The marine vegetation and marine animals. But since the product was liquid, the liquid started moving through rocks and ended up traveling far and wide and got trapped in different places, right? So, of course, some oil is there over the seashore and even in the sea, but a lot of oil has moved because it is a liquid product. The coal is a solid, so it stays where it was formed. But oil, being a liquid, has had the luxury of traveling from its origin to its destination. Destination is where it got trapped. It couldn't move further, so phas gaya, right? So keep in mind, then full ascendancy of the biogenic hypothesis began in the mid-20th century with the convergence of scientific advances in paleontology, geology, and chemistry. In 1936, Alfred Tripps established a link between chlorophyll in the living organism and porphyrin in petroleum. Remember, all plants, they have chlorophyll with which photosynthesis is done. And crude oil has porphyrin. And porphyrin is similar to chlorophyll. So this is one way to say that, yes, porphyrin in petroleum must have something to do with chlorophyll in the plant from where it formed. Okay, beautiful theory. Additional geochemical evidence followed with discoveries that low to moderate maturity oil still retain hydrocarbon fraction with optical activity 40. Optical activity, I think don't bother about this number, that the stable isotopes of carbon of petroleum bear a biological fractionation, and oils contain, in addition, this was taken from a research article by an expert from, Exxon Mobil, origin of petroleum. Okay, and that oil contains, in addition to porphyrin, a host of hydrocarbons that can be traced back to specific biological precursors. Okay, so many field studies have recognized that organic rich strata occur in all petroliferous sedimentary basins, that is sedimentary organic matter. This sedimentary organic matter is known as kerogen. Remember, this is a new jargon for you. Like we had peat, subbituminous, bituminous, etc. Here, the organic matter, the starting point was called kerogen, right? It is a loose, what do you call a slush of hydrocarbon, right? But not fully formed. Kerogen is derived from biota, that is biological material. It has been chemically altered. So the starting mess of kerogen slowly moved stage by stage into other stages, and the kerogen and the sediment got buried and heated. More and more changes were happening to the kerogen. So you can see that this is a rock system where you have at least one formation of organic rich sediment, right? So you have the rock where it has formed and then it has moved and got trapped, right? So, and this is a cap rock, right? So you can see this cap rock, right? And the oil has got trapped, right? So somewhere the gas also got trapped. Somewhere the oil and gas were together. In other places, it was only gas and no oil. Okay, so this figure in a short way gives you what is happening below the earth in terms of the oil formation. Okay, so you have the source rock, reservoir rock, all that is put out here, right? Sealing rock, low permeability and structure, that is a cap rock, sealing rock, right? So you can see this arrow represents the gas migration, right? And the thick arrow represents the oil migration. Okay. Although derived from biochemicals, the sedimentary organic matter in source rocks is markedly different in structure and chemical composition. Living organisms are composed mainly, see, all living organisms have protein, nucleic acids, and lipids. Structural materials such as lignin and cellulose and various resins are fairly well defined biopolymers. Remember, wood has got cellulose and lignin, right? So, biological material. And living organisms like the what is that? Big animals, they all have protein, nucleic acids, and lipids, right? Kerogen formation begins at the point when living cells die and their biochemicals are exposed to geological environment. So when the living cells die and they are exposed to geological environment, kerogen formation starts. Microbial processes are responsible. Now, not much microbes have done the coal formation, but microbes seem to have played a very extensive role, especially in the formation of oil. Right? Microbial processes are mostly responsible for breakdown of biological macromolecules and the recycling of lower molecular weight biochemicals, resulting in selective preservation of more bioresistive compounds. See, the chemicals which were not bioresistive, they all stayed back, right? Which were not bioresistive got broken up, and what happened was more bioresistive components. That which were not attacked by the microorganisms stayed back. Low temperature reaction alter the kerogen through loss of functional groups like ammonia, NH3, COOH, they all got lost. Sulfur coming, condensation, cross-linking, aromatization, right? The aromatization is, remember, a straight chain hydrocarbon forming into a cyclic, and then from cyclic forming aromatic, right? Like N-hexane becoming cyclohexane and cyclohexane becoming benzene. It is a conversion of an aliphatic compound into a naphthenic compound into a aromatic compound. So the starting set of reactions which happened were in the range of, just about say 50 to 80 degrees, less than 80 degrees, and this is known as diagenesis. Right? Diagenesis is where some of the very simple reactions happen to kerogen to start forming hydrocarbons. So first stage is diagenesis. Then subsequently we come to what is this catagenesis. Catagenesis is where some bond breaking is happening. Carbon sulfur bond, carbon oxygen bond break preferentially during the early stages of catagenesis. Remember, diogenesis is happening to kerogen. Kerogen is our starting point. When the living cells die, what is remaining is known as kerogen. Kerogen at about 50 to 80 degrees undergoes a diogenesis to form a set of hydrocarbons, which further undergoes in the range of 150 to 175 degrees, what is known as catogenesis, where some bond breaking happen. They end up producing bitumen, right? And polar compound containing NSO is nitrogen, sulfur, oxygen, right? With additional heating, right? So diogenesis happened below 80 degrees and catogenesis is happening above 80, somewhere between 90 to 175. Then in the next stage comes metagenesis. This happens over 200 degrees centigrade. They take place under still more severe thermal alteration. The temperatures are high, where only methane is produced as methyl groups, cleavage from highly condensed aromatic structures. So metagenesis. So you have three things. First is kerogen formation. When living cells die, they end up as kerogen, and kerogen undergoes diagenesis below 80 degrees to form hydrocarbon. And next stage is catogenesis, which is in the range of 150, 175, where some more bonds break and hydrocarbons are getting formed. And the last stage is metagenesis over 200 degrees, where some methane formation is happening. So keep in mind the story from living cells, kerogen, diagenesis, atogenesis, and metagenesis. And oil generation is a kinetic process, right? Both time and temperatures are critical. On one generated from the kerogen, petroleum is expelled. Remember, where is all this happening? All these kerogen, diagenesis, cato and metagenesis, they are all happening in the source rock. They are happening in the source rock. And once the formation takes place, the petroleum is expelled into mineral pore spaces, primary migration, and then through permeable rock and falls to the trap, secondary migration. Oil expelled from a source rock is enriched in saturated and aromatic hydrocarbon relative to the bitumen that remains. Right. And the molecular and isotopic composition of produced petroleum is determined by complex chemical, physical, and biological processes. Remember, the physical changes happening, chemical changes happening, and biological action happening, all this converted the organic matter into crude oil. Right? Generation and expulsion from the source rock, phase behavior as petroleum moves from source to reservoir. Reservoir is where the accumulation and collection happen, and reservoir, the fill history, and secondary alteration processes all influence oil and gas composition. So how oil formed determines its composition. That is, to what extent diagenesis happened, catagenesis happened, metagenesis happened, will determine what type of hydrocarbons are present in the crude oil, and that is how the classification of the crude oil will be done. Okay, we'll come to that. One generated and expelled, from the source rock, petroleum can be further modified during migration and entrapment within the reservoir. In most petroleum systems, the source formation is at greater temperature and pressure than the reservoir, and migrating petroleum fluid may separate into gas and liquid that can then migrate independently. Right? So the gas and liquid may separate, and the gas may migrate independently, where you end up with gas well, and the liquid may travel separately, where the gas will be little. Right? Petroleum also interacts with water, and more soluble hydrocarbons may selectively partition into the aqueous phase. So, what do you call it? With water, it's forming a sort of oil is forming. When you see pour, oil in water, you'll see a colloidal formation. So such a formation is happening. Once in the reservoir, secondary processes can alter the oil composition, biodegradation, and the consumption of hydrocarbons by microorganisms. They're all likely to occur in shallow, cool reservoirs, less than 80 degrees C. This process selectively removes saturated hydrocarbon, enriching the residual crude oil in polar and asphaltic material. Biodegradation forms acids and biogenic methane, carbon dioxide, and H2S. Okay. Then the composition of crude oil that arrives at a refinery is not identical to the reservoir fluid. How come? That is, what is happening at the drilling point and what is arriving at the refinery, they may not be the same. Because gas and water is separated at the wellhead and emulsions are broken, and consequently oils lose some light hydrocarbons by evaporation during production and transport. And pipeline and tankers, they are actually bringing blends of oil from multiple fields and reservoirs, which individually may be varying composition and quality. So the tanker is actually having oil from multiple wells, so the composition may not be equal to the composition from any particular well, right? Now to quickly summarize the origin of petroleum. The theory that petroleum originates from sedimentary organic matter that was once living organism is consistent with all natural observation, laboratory analysis and experiment, theoretical considerations and basis. That is, biogenic formation of crude oil is well accepted in the scientific world. Right, the accumulation of economic quantities of petroleum requires that a series of processes occur within the sedimentary basin. Organic rich sediments are deposited only under specific conditions that promote the production of biota and transport of biogenic organic compound and the selective preservation of this material. Sedimentary matter converts to kerogen, an insoluble macromolecule with a composition that reflects the biotic input and chemical alteration from sulfurization, condensation, defunctionalization, and aromatization that occur during diagenesis. See, during diagenesis, many reactions are taking place into the convert the kerogen into crude oil. And once lithophile, what is lithophile? Lithophile is where the sedimentary rock becomes like a stone. Remember, sedimentary rock is like a little soft, loose material, but when it lithifies means it starts becoming a hard rock, right? Not hard rock cafe, right? So the soft rock becoming hard rock is lithification. Lithophile, these organic rich strata have the potential to generate oil and gas when buried and heated to promote thermal cracking. So due to heat, some long hydrocarbons break into smaller hydrocarbons. Cracking means tod dalo, break it, right? Crack it. So long chain hydrocarbon start breaking into small chain, and the expelled petroleum migrates from the source through fractures. Fractures means cracks in the rocks and permeable strata. Economic reserves occur when geological conditions allow for the accumulation, retention, and preservation of significant volumes of migrated petroleum. So when a favorable condition where it can get trapped, then it doesn't move any further. There it stays till you find it and start drilling. Right. Collectively, these processes describe the petroleum system. Just imagine, petroleum exploration is not a one-day, two-day affair. Just look at this chart, right? In exploration, we get the information required to exploit the best opportunities, and an oil company may work several years before completing the exploration. So there is the initial evaluation, which could take roughly 2 years, just more than 2 years. Then a geological survey, which extends from the middle of second year to somewhere the third year. Geophysical survey, geological survey is rocks and flora and fauna in the place where origin of petroleum is likely to happen. Geophysical survey, we will see shortly what all is done. A whole lot of data is collected, gravity data, magnetic data, electrical data, shock wave transmission, etc. All that happens in geophysical, which may take so much time, years, somewhere in the middle of second year till the middle of fourth year, and drilling. Then toward the end of fourth year, drilling starts, and then drilling. This is a test well, and then the production well. Then this is how so much drill, continue. So many decisions have to be made. Okay, exploration is responsible for handling the risk intrinsic. Remember, exploration is a high risk activity. I may not find oil. I may just spend time and find that no oil is present. But to prove that no oil is there, you have to work. Right? And this is generally achieved by a selection of a range of options in probabilistic and economic terms. Indeed, exploration is a risk activity, and the management of exploration assets and associated operations is a major task for oil companies. Okay, then the risk cannot be eliminated entirely, but can be controlled. We cannot eliminate the risk, but we can control and reduce, adopting appropriate workflow. Right? It can be controlled and reduced. Risk cannot be eliminated. Right? By a better way of working, we may be able to control or reduce the risk, but we can't totally eliminate the risk. There will be still that after spending a lot of time and money, you may find no oil is found in that place. Right? When it has been decided to start up with an exploration project in a basin or a large area consisting several basins, the quantity and quality of available data must be acquired and evaluated. You have geological data, types of reserves, production of existing fields, if any, etc. Basin assessment evaluation is the first step to undertake the study of the area under interest. Technological development has provided oil companies with basin modeling, which is a numerical solution that allows the temporal reconstruction of the history of sedimentary basin and associated evolution of the process relating to the formation of petroleum accumulations. So basin modeling and petroleum system, right? So here you can see very bright oil trap. This part is gas trap. Here where the oil and gas is formed, they are going by separate routes to the oil trap and to the gas trap. And some gas migrates also and may go entirely to a different place where drilling will end up producing gas only. On the basis of, there is a lot of computer applications in the exploration. So on the basis of data and evidence collected from the preliminary studies, the company management discovery G&G. G&G stands for geological and geophysical data. Aside from considerations of an economic nature, may decide to move to the following stage, which is the acquisition through direct negotiations or by taking part in bids of the legal right to perform prospecting in the selected area or block. Permission for drilling, right? A typical sequence of activities will be creation of a database, the analysis of available data, programming of the mapping and geological and photogeological surveys, seismic surveys, and interpretation of seismic data, the choice of well location, drilling, analysis of results, once the decision is to whether or not to proceed with the application for lease or to release the area after fulfilling the application. So many things have to be done in the exploration. Now, goal of exploration is to identify and locate a prospect, means where prospect means jahan pe oil milega, to quantify the volume of hydrocarbon which might contain how much, whether there is a location, if the location is there, how much volume it contains. And in making this, there is always a risk involved, right? And a project is viable target evidenced by geological and geophysical indications, that is G and G, right? That is recommended for drilling and exploration well. There you have identified the prospect, that is likely place where oil is to be found. Prospects identified must be technically practicable and meet the market condition to guarantee a financial return on the investment. The results obtained by drilling the explorative well, they indicate whether the initial geological hypothesis is correct or whether variations are found. Okay, all this will allow the fine-tuning of the economic analysis of the project, possibly by turning hypothetical reservoirs into proved ones. Hypothetical means assume. Proved means pakka hai. Right? Where profitability does not meet the standards of company, it leads to the termination of the further investment. So look like when I find that not much oil is coming, I'll put an end and pack off. Now, let's look at the main exploration. This is geological survey, geochemical prospecting. This is, searching for rocks, etc. Then this is remote sensing, satellite and aerial photography, right? Aerial photography and remote sensing satellite images They help you in locating possible oil location. And this is airborne gravimetry and magnetometry, where you have gravimetry is where gravity studies, measurement of gravity is done. Magnetometry is studying the magnetic properties, right? And seismic survey. Seismic survey is a very intricate step. It is something like in the area where oil is to be found, put detonators in a scientific way in a grid form and pull the detonators. Detonators are dynamite sticks, right? So they explode and leading to cleavage of the place where the explosion took place, from where we will get clue of about oil and its story. Geological mapping and prospecting. So geological mapping and prospecting, these are valuable techniques in petroleum exploration. The mapping, it is basically a technique which allows graphical presentation of geological observations and interpretation. And geological prospecting makes use of geological disciplines such as petrography, stratigraphy, sedimentology, structural geology, geochemistry. All these fields go to success of this. And such disciplines are used to achieve different targets, but it must be stressed that their integration is fundamental to depict the picture of reality. Okay. Let's now get going. So you have now the next. So geological mapping is collecting rock and plant samples and making an analysis, right? Whether they have something to do with the oil formation or not. Geophysical methods. Geophysical methods are different types. They involve gravimetric, magnetometric, magnetotelluric, seismic. What is gravimetric? Gravimetric, as the name suggests, is to find not gravity, right? So you have, remember, all over the earth, the gravitational force is not the same. There will be a slight difference between the G value in a location where oil is happening and in a location where oil is not happening. So very precise measurement of the G value can give you a hint whether there is a oil there or not. Then comes magnetometric, studying the magnetic properties of the place where oil is suspected to be found. So magnetic properties will be different. That analysis is done. The third one is magnetotelluric. This is in short known as MT. MT means magnetotelluric. This stands for electromagnetic geophysics. Electromagnetic geophysics means you are measuring both magnetic properties and electrical properties. Right? That is how you must remember. Magnetotelluric means magnetic properties as well as electrical properties. Then comes last seismic. Seismic is, I told you, like in the area where oil is to be found, I'll put, dynamite sticks and ignite. Right? So it causes a a mini explosion, leading to, let's say, similar to what an earthquake would have done. So the shock waves, which is made by detonation of the explosive, is, the shock wave is transmitted. Now, the way the shock wave transmits in an oil medium and in a non-oil medium are known. So by studying the seismic analysis, I will be able to tell whether there is oil present in that particular location or not. Gravimetric is geophysical technique where gravity acceleration generated by contrast in density among bodies in the subsurface. Gravimetric prospecting is used to reconstruct the main structural element. So gravimetric prospecting is giving a good clue of whether oil is found or not. Right. Similarly, magnetometric, measuring the local anomalies in Earth's magnetic field. The method enables the acquisition of data on structural characterization and on the thickness of the sedimentary overburden and identify the presence, depth, and extension of volcanic or plutonic masses within the sedimentary sequence. Okay, so this is magnetometric. Primarily focus is on magnetic properties. Then comes seismic prospecting. Seismic has become the most valuable technique to reduce exploration of risk being unsuccessful in locating a prospect. Okay, so the technique is based on determination of time interval that elapses between the initiation of a seismic wave. The seismic wave is nothing but when I burst the explosive, so the shock waves travel from one point to another. So where I capture the shock wave, I analyze, right? So by analyzing the shock wave, it is possible to predict whether that particular location has a oil reserve or not. Okay. And geophysicists interpret the process seismic data and integrate other geoscientific information from where it can be, where oil and gas may be accumulated. You have supercomputers doing the job, rapid data allocating, rapid data loading, a high-speed networking, high-resolution graphics, visualization centers. They all provide the ability to display and manipulate complex volumes of 3D data, resulting in better interpretation. Right. So these are some of the highlights of the techniques. Then comes the drilling the exploration well. Exploration well means trial, like a trailer, right? So once the geological and geophysical, in short, GNT information is available, right? So a go ahead is given for a trial drilling well, right? The drilling of the well is aimed to confirm the presence of petroleum accumulation, just to prove that yes, it is there or not. Then well logging. Well logging consists of lowering the logging tool, well logging, that is maintaining the records of the well, like logging logbook, right? The well logging helps you to help geoscientists and engineers to understand the presence of reservoir and the presence of hydrocarbons and their characteristics, reservoir properties, etc. So these drilling, the exploration well, well logging, they are all happening at the place where the oil is found. Then comes coring. Coring is the only method of obtaining high quality sample by direct measurement of rock and reservoir properties. Core samples are used to perform routine core analysis and or special care analysis to obtain the detailed petrophysical data. Coring. So you have drilling, water logging, coring. Once coring is done, then well testing. Well testing is the measurement of various factors, right? And what is the quantity of oil, quality of oil, how much gas is present, what are the difficulties, impurities, all that is done in well testing. And the acquired information is used to determine whether a reservoir capabilities and important decisions such as production method, well production, or remember it was done for a particular method And once the method changes, then the subsequent change also may happen. Okay. Composition of crude oil. Now time has come to look at composition of crude oil. We know it contains hydrocarbon, carbon, hydrogen, and also sulfur, nitrogen, oxygen in combination with the hydrocarbon, metals and organic nickel, vanadium, iron, inorganic sodium ion, sodium, calcium, chlorine, compound that contain only elements of carbon and hydrogen or hydrocarbon and constitute the largest group of organic compounds found in petroleum. There might be as many as several thousand different hydrocarbons in crude oil. Hydrocarbon compounds have a general formula CXXY, where X and Y are integer numbers. Okay, now look at this. So I have crude oil. There may be organic compound, nickel, vanadium, iron, and this side I have hydrocarbon containing only carbon and hydrogen, heteroatom compound, that is hydrocarbons containing sulfur, nitrogen, oxygen, etc. And then you have the metals also. Right, you have the metals also. Hydrocarbons may be paraffin, olefin. Paraffins are aliphatic saturated compound. Olefins are unsaturated compound. Naphthenes are cyclic compound. Aromatic or benzene-like. Right, remember, that is not cyclic. Aromatics are different from cyclic. Cyclohexane is different from benzene. Right. Among these groups, paraffins, olefins, and naphthenes are called aliphatic, as different from aromatic, benzene and co. Right. The lightest hydrocarbon found as dissolved gas is methane. The main component of natural gas is methane. Olefins are not usually found in crude oils. So you may not find ethylene, acetylene, propylene in the crude oil. We may have to do it subsequent reactions, establish that these olefins can be formed. Otherwise, presence of olefin in crude oil is almost zero. Right. So the essential components are carbon-hydrogen compound linked by a single bond, linked by a double bond alkene, and located by conjugated double bond in ring structures. Saturated aliphatic, HCN alkane, you have a general formula. Right. So these are all the possible organic chemicals that can be found in crude oil. Now let's analyze the elemental analysis of crude oil. Carbon 84 to 86%. Hydrogen is 11 to 14. Sulfur is 0 to 6. Nitrogen is 0 to 1. Oxygen is 0 to 2%. So you have now the elemental analysis. The narrow range, carbon is just 84 to 86, hydrogen. If it is a wide range, you can say low carbon crude, high carbon crude. But when it is only 84 to 86, it becomes difficult. So with such narrow ranges, you can't use this, ranges to decide what type of crude oil. I must use what is known as this ternary diagram. Ternary diagram is like a triangle, a very interesting way of data analysis. Right. So I have at this vertex 100% aromatics. When I say 100% aromatics, it is 0 here, 100% naphthene, 100% paraffins. Right, draw line 20, 40, 60, 80, 100. Right, and depending upon how much paraffin, how much naphthene, and how much aromatic is present, we can classify the oil. So based on composition, we can classify. Let's look at some of the classification. There are many classifications. Class 1 to class 6. Class 1 is rich in paraffin. This represents the most desirable type of crude oil because refining this crude will readily lead to high yields of light and middle distillates that will constitute fuel such as gasoline. And you have now the extensive refining will be required to make the aromatic structures. Class 1 crudes have higher degree API. API is the American Petroleum Institute measurement, right? You have done it in the chemical process calculation, and low sulfur content and tend to be more expensive than other types of crude oil. So class 1 is the best and it is the most expensive also. Just look at this. I have 6 classes of crude oil. 1, 2, 3, 4, 5, 6. One is paraffinic crude. Paraffin plus naphthalene is greater than 50%, in which paraffin is more than naphthalene, and paraffin should be at least say 40%. Then such a crude is class 1. Class 2 is naphthenic, where naphthenes are more than paraffin and naphthenes are more than 40%. So paraffinic crude, naphthenic crude. Then where it is the split, then paraffinic naphthenic crude. Aromatic is less than 50, paraffin is less than 40, naphthene is less than 40. Right, in such a case it is paraffinic naphthenic. Then comes aromatic naphthenic, where aromatic is more than 50%. Then aromatic intermediate, aromatic is more than 50%. Aromatic asphaltic, where naphthene cyclic compounds are 25% and paraffins are less than 10%. So these are 6 classes. Then you have API gravity. Just a few minutes more, please. You know the definition of API gravity. We have done it in units and dimensions in the chemical process calculation. API gravity is 141.5 by Sg minus 131.5. It is a very special measure for crude oil, where Sg is the specific gravity at 60 degree F. When this value of API is more than 31.1, it is called light crude. When the API value is 22.3 to 31.1, it is medium crude. And when it is between 10 and 22.3, it is heavy crude. And when it is less than 10, it is extra heavy. So you know that light crude is what is the best one. API gravity more than 31.1. Actually, API gravity is something relative to whether the oil is denser than water and will sink or not. So API is actually measuring. Sg means, remember, relative, specific gravity, ratio of densities. Okay, so here what we are seeing is, actually we are seeing whether the API gravity, this is whether the oil is denser than water and will sink in it or not. Okay, so this is API based classification based on density. Density is less than 870 kg per meter cube, which is otherwise greater than 31.1. Remember, density and API are related by this formula, right? And so light crude means density is less than 870, medium crude means 870 to 920, heavy crude means 920 to 1000, and extra heavy means greater than 1000 kg per meter cube. That is extra heavy. Then comes based on sulfur content. If my sulfur is only more than 0.5, it is known as sour crude, katta. When it is less than 0.5, it is known as sweet crude. Now you'll be wondering, what is this? Actually, they literally used to, put a finger and put it in the tip of the tongue to see whether the crude is having sulfur or not. Right? So kata means sulfur crude and not kata means meta. Right? So that is how it came into picture. It's a very interesting thing how the name sour crude and sweet crude came. Less than 0.5 is sweet, more than 0.5 is sour. Sour crude is the problem, more sulfur. Right? Then classification based on wax content. If I have more than 5% wax in the crude oil, I call it paraffin based. And if I have less than 2%, it is asphalt based. This is another way of, crude oil classification is, many kinds. Then there is something called correlation index. Correlation index, CI, is 473.70 minus 456.8 plus 48,640 by K. where K is the petroleum fraction, um, average boiling point determined by standard Bureau of Mines distillation method. So there is a prescribed test method known as standard Bureau of Mines distillation method, and by that method the boiling point we get is K, and that is plugged into this equation, and or there we have an alternate equation 87,552 by TB. TB is the average boiling point, and this is relative to specific gravity at 60 degrees F. When the correlation index is 0, it is straight chain paraffin. When correlation index is 100, then it is benzene aromatic. Right? So you can say that correlation index may be between 0 and 100. 0 means paraffin, 100 means aromatic. Right? And values of this correlation index 0 to 15 means predominantly paraffinic. 15 to 30, that is, I am representing the CI value. If it is 0 to 15, paraffin crude. 15 to 50 means it is either naphthenic or mixture of paraffin, naphthalene and aromatic, and more than 50 means predominantly aromatic crude. Then you have a viscosity gravity constant known as VGC. It is done by this test method. ASTM is the American Society for Testing and Materials. This is a very highly reputed organization. They have defined the test method for finding the viscosity gravity constant. It is determined at 37.8 degrees centigrade, that is 100 degree F, and you put it in this equation, VGC, that is the viscosity gravity constant, is 10g minus 1.0752 log of V minus 38 by 10 minus log V minus 38, where V is the Seibold universal viscosity. You have done it in fluid mechanics, the units of viscosity, Seibold universal viscosity, and G is the specific gravity. So plugging in these values, we get VGC, right? And you have an alternate equation also for determining the viscosity gravity constant, and the G and V terms are defined, right? So this is another classification based on viscosity gravity constant. Then there is a special factor called characterization factor K. K factor, or it is known as Watson factor, or KW, this is not kilowatt. This is K factor Watson, KW. UOP, the company, UOP characterization factor, all mean the same. It measures aromaticity, paraffinicity of a crude oil, and it is given by this equation. K value is square root of TB by specific gravity at 15 degrees C. So the boiling point is by a standard test, and the specific gravity is by a test method, and based on this we get the K value. Okay, and based on the K value, we can tell whether the crude is paraffinic, aromatic, etc. Right? So you can see when K factor is 11 to 12.9, it is paraffinic. And when K value is 10 to 11, it is naphthenic. And it is below 10, it is aromatic. Okay, so this is characterization factor. Then there are many other factors. Viscosity, pour point, nitrogen content, total acid number, metal content, carbon residue, basic sediment and water, how much salt is there in the crude, distillation and boiling point, all this must be got. So I'm only making the various viscosity measurement is required, because otherwise you will know that whether the crude oil will flow or not. Flow properties is determined by viscosity. So viscosity has got standard tests, right, which are prescribed by the standard ASTM standard, and the viscosity value is a laboratory experiment to calculate the viscosity, right? And pour point is the lowest temperature at which the oil will pour or flow when it is cooled without stirring under standing cooling condition. See, when I pour something, will it pour or not, flow or not? Suppose it is just sticking to the vessel and not flowing, highly viscous. So pour point and viscosity are highly related. Pour point refers the lowest temperature at which oil is capable of flowing. Remember, in the winter, the coconut oil freezes and you put it in a cup of hot water, the oil melts. So viscosity is influenced by the temperature. So as the temperature increases, viscosity decreases. So pour point is actually measured at the lowest temperature at which the oil will flow under gravity, right, without any pumping, right? So pour point is a very important parameter. This is determined by this ASTM test method. And then you have nitrogen content, how much nitrogen is present in the crude, because it will affect the refining methods, right? Total acid number will tell you how much, whether the crude is acidic or not. It is done by a titration with potassium hydroxide, and how much potassium hydroxide is required will tell you what is the acidity factor of the crude oil. And then metals content, by different studies, we find out the presence of nickel, vanadium, iron, copper, etc. in the crude oil, and carbon residue, right? So how much carbon, when I burn the crude oil, how much residual carbon is left, right? So that is known as, coking temperatures. Like coking of coal, we can do coking of the crude oil also to form petroleum coke, right? So you have standard ASTM test for determining the carbon residue, how much coke formation will take place, and you have sediment and water, how much of soil and water is present, then salt content. So down to earth, some sodium chloride may be present, and measurement of salt content by standard experimental method. Then a series of distillation experiment is carried out to measure different boiling point, right? So to determine the refining procedures, and these are all done, right, by various laboratory methods, and you get a list called crude assay. It is like, you go for a comprehensive, health checkup, you get a, printout of your BP, what is that, fat content, lipids, that, all that values. Similar to it, it is like what do you call, a survey of the crude oil. It will list the API gravity, total sulfur, pour point, viscosity at 20 degrees, viscosity at 40 degrees, nickel content, vanadium, because many catalysts are used in refining. So the presence of these metals may influence or affect the catalyst. So they must be assessed. That is why it is known as crude assay, right? So like your health checkup, the crude oil has undergone a checkup to get all these parameters. Total acid number by titration with potassium hydroxide, distillation data, characterization factor, all this is in a printout. Okay, so that is your crude assay. And how do you determine the crude oil price? See, the crude which contains less sulfur is more expensive. The light crudes are more expensive. And you have the British oil wells, that is the Brexit, right? That is the one way, that is the North Sea oil in Europe, and the other is Texas. So there is a Texas model for pricing, and there is a this Breck model for another type of pricing, that is from the North Sea exploration, right? Then the transportation. Okay, so that is about the upstream, and in the next lecture we move downstream. There is not much to talk about midstream except that it is a transport by pipeline and insurance, etc. Right? Then in the next lecture we move to downstream, where in the downstream, in a nutshell, the crude oil unfinished products enter the downstream and come out as finished products. That is our downstream. We'll take up in the next lecture, and what happens is what we are going to see in the next lecture. All this is happening. Atmospheric distillation, cracking, reforming, alkylation, blending. So we will take up isomerization, right? So cracking, reforming, alkylation, isomerization, right? So all this hydrocracking, many such things are happening in downstream, which we'll take up in the next lecture. So the top 10 oil companies in the world are China Petroleum, China National Petroleum. You are in terms of sales, 424 billion. And third is PetroChina. So top three are Chinese companies in the global oil. Right? You start learning Mandarin, I think. Right? And maybe you'll get a job in the China Petroleum. Then Royal Dutch Shell, $345 billion. Saudi Arabia, Saudi Arabian Oil, then BP, British Petroleum, 278 billion, Exxon Mobil, Total is the name of a company, Chevron, Rosenfeld, and among the oil and gas companies in India, you have the Indian Oil, IOC, ONGC, Bharat Petroleum, Reliance Petroleum, SR Oil, Kain India, Gas Authority, GAIL, Hindustan Petroleum, HPCL, Oil India, OIL, right? And Tata Petrodyne. So these are all some of the Indian companies. You have the global companies. So there's a lot of exciting opportunities in the oil industry. We have seen the upstream today. We will catch up with the downstream in tomorrow's lecture. Thank you all. Bye. Have a great day. Bye. Hello.
Yes. Thank you, sir.
Thank you all. Thank you.
Thank you, sir.